Hello, and welcome to Module 7.3, Elimination Using Addition and Subtraction. Our objective for today is that I can solve systems of equations by eliminating a variable using addition or subtraction. Our vocabulary. The elimination method is using the addition or subtraction properties of equality in order to find our solution, which, if we don't remember, that is when if we add the equal things on both sides of an equation, the resulting equation is still going to be true. And so that's what we're going to be working with. Now, when do we want to use addition? We're going to use the addition method when we have variables with opposite coefficients. And we're going to use subtractions when we have variables with the same coefficients. All right, so let's start walking our way through the elimination using addition. Our first step says identify if the coefficients of one of the variables are additive inverses. In other words, identify if one of the variables has the same number at opposite signs. And as I look at that, I have that right here with the 6y and negative 6y. So my first step is going to be adding these two equations together. 5x plus 3x is 8x. Negative 6y plus 6y cancels out, and that's going to be equal to negative 32 plus 48 is 16. Now, my next step is to divide both sides by 8, and I get that x is equal to 2. Now, I'm going to substitute that value into one of my two equations. Which equation I use, it doesn't really matter, so I'm going to use the top one. 5 times 2 minus 6y is equal to negative 32. Now, my next step is to multiply. So we've got 10 minus 6y equals negative 32. We're going to subtract 10 from both sides. Negative 6y is equal to negative 42. And then we divide by negative 6. We get that y is equal to 7. So my ordered pair is 2 and 7. Now my next step says check my answer using substitution with the x and y coordinates, but we're going to use the other equation, the one we did not use in step 3. So that'll be the bottom equation. So we're going to substitute that in. We've got 3 times 2 plus 6 times 7 is equal to 48. 3 times 2 is 6. 6 times 7 is 42. And when we combine like terms, 48 does equal 48. So our solution checks out. That's the beauty of systems of equations. You can always check your work to make sure that your answer is correct, and you could verify that you are correct every single problem that you're going to do. All right, let's take a look at example A. I have 3x and negative 3x. Those are my additive inverses. So we are going to add these two equations together. 3x and negative 3x cancel out. 4y plus 2y is 6y. 16 plus 8 is 24. Divide both sides by 6. Y equals 4. Now I'm going to substitute that into one of my equations. So 3x plus 4 times 4 is equal to 16. 4 times 4 is 16. We're going to subtract that 16 from both sides, and we get 3x is equal to 0, which we can divide by 3. We get x is equal to 0. So my ordered pair is going to be 0, 4. And I'm not going to require you to go through the work every single time with checking your answer, but if we just did it for this one, we've got negative 3 times 0, that's 0, goes away. 2 times 4 is 8, which is equal to 8, so our equation is true. 0, 4 is our point of intersection. All right, letter B. We have opposite values or opposite integers in terms of the variable y. So we're going to add these two equations. X plus x is going to be 2x. Negative y and positive y cancel out. 12 plus 2 is 14. Divide by 2 on both sides. X is equal to 7. Now I'm going to use my top equation. 7 plus y is equal to 12. We subtract 7 from both sides. Y equals 5. My ordered pair then would be 7, 5. Make sure you're writing your ordered pair at the end when you get your solution. That is the solution of these two equations. So you do need to write it as an ordered pair because it does represent the point in which these two lines are going to intersect. All right. Letters C and D are U-try problems. Please do those on your own now and check your work against mine. All right, letter C. We're going to start off with, we add these two equations together. Negative 5 and 5 cancel out. 3y plus 2y is 5y. 31 minus 16 is 15. Divide by 5. Y is equal to 3. Now we substitute that back in. We have 5x plus 2 times 3 is equal to 31. Why did I pick this one? I picked it because everything was positive. It doesn't really matter. You'll get the same answer no matter which way you approach it. Subtract 6 from both sides. 5x is equal to 25. And we go ahead and divide by 5. X is equal to 5. So my ordered pair would be 5, 3. Letter D. We're going to go ahead and add these two equations together because positive 2y and negative 2y are opposites. So when we do that, 3x plus 4x is 7x. The y's cancel out is equal to 14. Divide both sides by 7. X is equal to 2. And we're going to substitute that in. So we're going to do 4 times 2 plus 2y equals 14. 4 times 2 is 8. We are going to subtract that 8 from both sides of our equation. 14 minus 8 is 6. And then we're going to divide that by 2, and we get y is equal to 3. So my ordered pair is 2, 3. All right, so let's take a look at our next example, which is write and solve a system of equations using addition. So letter A, 7 times a number minus 4 times another number is 13. So let's take that sentence and break it down. 7 times a number, 7x, minus 4 times another number, minus 4y, equals 13. Negative 7 times a number, negative 7x, plus 7 times another number, plus 7y, is 14. So we're going to go ahead and combine these two equations because our x terms are opposites. So negative 4 plus 7 is 3y, and 14 plus 13 is 27. And then we're going to go ahead and divide by 3. Y is going to be equal to 9. And we need to find our second value. So let's just take the first one. 7x minus 4 times 9 is equal to 13. So we go ahead and multiply 7x. 4 times 9 is 36. So 7x minus 36 equals 13. Okay, and then we're going to add 36 to both sides. We get 7x is equal to 49. And we divide by 7. X is equal to 7. So my ordered pair is 7, 9. Now, letter B, we've got 2 times a number minus 6 times another number. So we have 2x minus 6y is equals -6. -6. My second sentence, -2 times a number, -2x, plus 5 times another number, plus 5y, is 18, equals 18. Add these two equations together. My x values are my opposite signs, and we get those to cancel out. -6 plus 5 is -y, and 18 plus -6 is 12. So we need to divide both sides by -1. Y is equal to -12. Now we're going to substitute that into our equations. I'm going to use the top one. 2x minus 6 times -12 equals -6. So -6 times -12 is going to be 2x plus 72 equals -6. Okay. We're going to subtract 72 from both sides, and we get that 2x is equal to -78. 78 divided by 2, x is going to be equal to -39. Not -39, +39. So we have our points at 39, -12. All right. Now we're going to go on to the next page. These two are you tries. Go ahead and try those, and then check your work against mine. First sentence, -4 times a number plus 4 times another number is 0. 4 times a number minus 7 times another number is 18. So we add those two equations together. 4 and -4 cancel out. 4 minus 7y is -3y is equal to 18. Divide by -3. Y is equal to -6. All right, now let's use the bottom one. We'll do 4x minus 7 times -6 equals 18. We need to multiply 4x. -7 times -6 is plus 42 equals 18. And now we are going to subtract 42 from both sides. $4x is going to equal -24, which we're going to divide by 4. X is equal to -6. So -6, -6 are my ordered pairs, or is my ordered pair. All right, letter D, we have our first equation. A number minus 3 times another number is 7. We have 3 times a number plus 3 times another number is 9. So add our equations together. 3x plus x is 4x. The y's cancel out. 9 plus 7 is 16. And we divide both sides by 4. X equals 4. So now we do 4 minus 3y equals 7. I subtract 4 from both sides. -3y equals 3. And we divide by -3. Y equals -1. So we've got 4, -1 is our ordered pair. All right. Example 3 is basically the same process, except we're going to be using subtraction instead of addition. And so what we're looking for on this, we're looking for one of our variable terms to be the same values, the same coefficients. And we see that the y's here are both positive. So that means I am going to subtract one of these equations from the other. Now, this is where it's tricky, and this is where I'm not always the biggest fan of subtraction. I would rather us multiply, which is something we'll learn about in our next lesson. But for right now, we're going to do subtraction. And the key to remembering how to do subtraction correctly is that you need to distribute that negative sign. That subtraction, every single piece in the second equation is being subtracted from its corresponding piece in the first equation. So we're going to have negative 2x minus 7x, which is going to give us negative 9x. Positive 3 minus positive 3 is going to cancel out. And then we have 48 minus 21 is going to give us 27. Now we divide both sides by negative 9, and we get that x is equal to negative 3. And now our work becomes exactly like what we did before, where we're going to substitute that negative 3 value into one of our equations, and we are going to solve. So I'm going to take the first equation. I'm going to say negative 2 times negative 3 plus 3y is equal to 48. First steps, we multiply, so we get 6 plus 3y equals 48. Subtract 6 from both sides. We get 3y equals 42. And when we do 42 divided by 3, we're going to get that y is equal to 14. All right, so now that we have that, we are going to put our ordered pair together. So we have negative 3 and 14. Now let's check our work with our second equation. We have 7 times negative 3 plus 3 times 14 is equal to 21. So 7 times negative 3 is negative 21. 3 times 14 is 42, equals 21. And negative 21 plus 42 is 21, and that does in fact equal 21, so we are correct. All right, let's go on to the next page, and we are going to do some practicing with this. So in letter A, you can see that my x terms are going to be the ones that we need to cancel out because they are the same sign and the same value. So we're going to subtract. So 17 minus negative 17 cancels out. 13y minus 2y is going to be 11y. And 57 minus negative 20 is going to be equal to 77. We divide both sides by 11, and y is equal to 7. So we are going to substitute that into one of our equations. It really doesn't matter which one. I'm going to pick the bottom one. So we have negative 17x plus 2 times 7 equals negative 20. Now, when I multiply, we've got negative 17x plus 14 equals negative 20. Subtract 14 from both sides. Negative 17x equals negative 34. And we're going to divide by negative 17. We get x is equal to positive 2. So my ordered pair is 2, 7. Again, you can check your work. I'll let you do that on your own. Letter B. It is my y values that are the same value, so I'm going to subtract. So we have 2x minus negative 5x. That'll give us 7x. The y's cancel out. 9 minus 30 is negative 21. Divide both sides by 7, and we get x is equal to negative 3. We're going to substitute that in. We have 2 times negative 3 minus 3y equals 9. 2 times negative 3 is negative 6, minus 3y equals 9. We're going to add 6 to both sides. Negative 3y equals 15. And we're going to divide by negative 3. We get y equals negative 5. So my ordered pair is negative 3, negative 5. All right. Letter C and D are you-try problems. Do those on your own and then check your work against mine. All right, so I see that my y values are both the same, so I'm going to subtract the second equation. 5x minus 2x is 3x. Y minus y is 0. And negative 3 minus 0 is negative 3. I'm going to go ahead and divide both sides by 3. X is equal to negative 1. So now we have 2 times negative 1 plus y equals 0. 2 times negative 1 is negative 2 plus y equals 0. And we're going to add 2 to both sides. Y equals 2. So my ordered pair is negative 1, 2. All right. Letter D, we're going to subtract because our x values are going to be the same. So 2x minus 2x is 0. 5y minus 9y is negative 4y. And 6 minus 22 is going to be negative 16. All right, now we need to divide by negative 4. Y is going to be equal to a positive 4, which I'm going to substitute in, let's do the first equation. 2x plus 5 times times 4 is equal to 6. We do the multiplication first. 5 times 4 is 20. And we're going to subtract 20 from both sides. We've got 2x equals 6 minus 20 is negative 14. Divide by 2, x is equal to negative 7. So my ordered pair is negative 7, 4. All right. So if we look at example 4, now we're writing and solving a system of equations that's going to use subtraction. So letter A carpenter is designing a drop leaf table with 2 drop leaves of equal size. The length of the table with 1 leaf up is 5.5 feet. The length of the table with both leaves up is 7 feet. How long is the table with no leaves up? All right, so let's just give you a verbal description. A drop leaf table is one of those tables where on the ends of it, you have an extension that just kind of folds down, and you could lift it back up if you want the table to be bigger, if you've got more people coming over, if you need to use a bigger surface. So that's what a drop leaf table is. So this one has 2 of these little arms that are going to come up or down on the ends, and then there's a middle section that's always going to be there. So our first sentence describing it, we've got the length of the table with 1 leaf up is 5.5 feet. Well, we don't know how big the leaf is, so I'm going to say our variables, right? We don't know how big the leaf is, and we don't know how big the base of the table is. So we're going to say table is x, and leaf is y. So in the first sentence, we have the length of the table with 1 leaf up, so plus x plus y is 5.5 feet. My third sentence here rather, the length of the table with both leaves up is 7 feet. So our base table plus 2 leaves is 7 feet. So this is a subtraction problem because we have the base table length, right? That middle section is there for both of them. So the x's cancel out. We've got y minus 2y, so that's negative y, is equal to 5.5 minus 7 is negative 1.5. And then we go ahead and divide by negative 1, and we get that y is equal to 1.5. And we're measured in feet, but that is the length of our leaf. The question is asking us, what is the length of our table? The table with no leaves. All right, so we're going to use that first equation. The base of the table plus the 1.5 for the leaf is equal to 5.5. And we're going to subtract 1.5 from both sides. And we get that x is equal to 4 feet. So that's our answer right there. Our table is 4 feet long. Each leaf is going to be 1.5 feet long that can fold up. And you would have a grand total of a 7-foot long table if you used everything that you had. All right, let's look at letter B. We've got 6 times a number plus 5 times another number is 39. So let's just take that first sentence. 6 times a number, 6x, plus 5 times another number, plus 5y, is equals 39. Now our second sentence, 3 times a number, 3x, plus 5 times another number, plus 5y, is 27, equals 27. So we're going to do subtraction because those y values are the same but opposite signs. So 6x minus 3x is 3x. 5y plus 5 or minus 5y cancels out. 39 minus 27 is 12. All right, now we're going to divide both sides by 3. X is equal to 4. Now we need to find our value for our y, so I'm going to use that second equation, and I'm going to do 3 times 4 plus 5y equals 27. 3 times 4 is 12, plus 5y is 27. Subtract 12 from both sides. 5y is equal to 15. Divide by 5, y is equal to 3. So your ordered pair for this one is 4, 3. Now, what's the difference between these two? Because, right, the first one I didn't necessarily write as an ordered pair, and this one I did. In my mind, the difference between these two is that in problem A, you were given real-world scenarios, so you are giving the units and the values of those two corresponding pieces, whereas this is kind of a generic equation. There's no real context provided for it, so we're just going to write it as an ordered pair as if we were graphing it on a coordinate plane. All right, we have letters C and D for you to try, and then we're going to check your answers against mine. Letter C, the drama club sells a total of 101 tickets to its first play. A student ticket costs $1 and an adult ticket costs $2.50, clearly before inflation. Total ticket sales are $164. So we have two equations to write based on this information. One of them is really contained in the second and third sentence there. A student ticket costs $1, an adult ticket costs $2.50, and the total ticket sales are $164. But first, let's define our variables. X is going to be student. Y is going to be our adult. So in that red equation there that I've underlined, student tickets are $1, so $1 times X. An adult ticket is $2.50, so plus 2.5 Y. The total ticket sales are 164. Notice how the units on that one, all three sections of it include dollars, right? That's maintaining our unit. That's that unit analysis that we did way back in chapters 1 and 2 and focused on the units that we're using and helping that guide our equation writing. Now, the other equation, we know we have a total of 101 tickets. So we're going to equal 101. What is that made up of? Well, that's our student tickets plus our adult tickets. Now, my x values, the student tickets, are both 1 in both of these equations. So we're going to use subtraction. We're going to subtract top equation from bottom equation. 1x minus x is 0, cancels out. 2.5y minus y is 1.5y. And 164 minus 101 is going to give us 63. And we need to go ahead and divide by 1.5 to get y by itself. And we're going to get that y is going to be equal to 42. So that's 42 adults. And we need to figure out, because it said how many student tickets were sold. That's our goal to find. So we have x plus 42 is equal to 101. And we just need to go ahead and subtract 42 from 101. And we get that x is going to be equal to 59 tickets. So that's 59 student tickets. That's the actual answer to the question that was asked. Side answer would be the 42 adults, but the actual question that the problem asked us to solve was how many student tickets were sold. All right, letter D. We have washing 2 cars and 3 trucks takes 130 minutes. Washing 2 cars and 5 trucks takes 190 minutes. How long does it take to wash each type of vehicle? So, step number 1, define variables. So, our x variable is going to be time for cars, car time, and our y variable is going to be truck time. All right, so our first equation, 2 cars and 3 trucks. 2x plus 3y takes 130 minutes, equals 130. Our second equation, 2 cars and 5 trucks, 2x plus 5y is 190 minutes. Now, in both instances, we had 2 cars that were being washed, so we're going to subtract these equations. The 2x's cancel out. 3y minus 5y is negative 2y, and 130 minus 190 is negative 60. And now I need to divide both sides by negative 2. Y is equal to 30 minutes for a truck. So it takes a half an hour to wash a truck. Now, if we go ahead and solve one of these equations, I'll take the first equation. 2x plus 3 times 30 equals 130. We multiply 3 times 30. 2x plus 90. Let me rewrite that. 2x plus 90 is equal to 130. So now we're going to subtract the 90 from both sides. So essentially we're taking away the time that was spent washing the trucks to get the total time spent washing the cars, which was 40 minutes. And then we're going to divide that by the 2 cars that we washed. And we're going to get that our time washing cars is 20 minutes. Okay. And that's how we do elimination using addition and subtraction. If you have any questions, please bring them to class tomorrow. Otherwise, have a great day.